But as we measure angles, it's very important for you to follow along certain things. This, of course, is called your protractor. And notice there are two sets of numbers. There's a set of numbers on the outside of it, and there's an entirely different set of numbers on the inside. So it all depends on where you begin your angle. So the key thing here is that most of you will have some sort of a crosshairs or something like that. That's where you place the vertex. And it never matters if you put the one side of the one side of the angle going this direction or one side going this direction. It doesn't matter. The key is that you interpret it correctly. Okay. So as we line this thing up, I have to get this circle or crosshairs to line up right here at this vertex. And then I'm going to set this blue 0 mark on this terminal side, or this beginning initial side. Again, you could have done it the other way so that you're actually doing it more like this, where you're lining up the red instead. Okay, so when I line this up right here as closely as possible, like so, now I am going to figure out where it crosses from this line over here, or this ray, somewhere like that. You might need to draw your sides a little bit longer. You might need to make some adjustments. So as I see, notice that I'm starting at 0 here because that's where I lined it up on the bottom. So that's my 0. So I'm reading from the outside now, 10, 20, 30, 40, 50, all the way. So I'm looking at the outside, and it looks like 130 or 131. 130 or 131. And now notice that I didn't have to have used that side. I could have rotated it this way and used the other side as what I would call my initial side. So now I'm lining up, in this case I'm calling it red, I'm lining this 0 up with this side over there. And I would check how this side over here interacts with it. And notice that again, I get to approximately 130 or 131, counting from this direction inside. 10, 20, 30, 40, all the way to 130 or 131. So, okay, so here's one way that we can label that, and I'm going to just use my precision and say 131 degrees like that, and that's how we label it. Another way to state it without using the diagram is simply like this. We can say the measure of angle A is equal to 131. Notice we do need to have the M in the front because instead of talking about a physical object, I'm talking about a characteristic. How wide does it open? So that's what the M means. The M means I'm not talking about the shape, I'm talking about a number related to it. I'm not talking about Swenson, I'm talking about his height, something different. So 131, hence now we use the equal symbol. All right, so the same thing over here, and we go ahead and attempt to measure this one. Something like this. And as I go in to see approximately how big it is, it looks like it will cross at the 25 or 26 degrees. 26 degrees. Now yours could be different. Don't change it if you got 26. I could be off. But if you got 27, 28, 29, or 24, okay. But if you wrote down 30, 31, punch yourself in the neck. Okay. So notice that this one we can call, again, we can say the measure of angle A is equal to 26 degrees. Something like that. We could use all three letters and say the measure of MAL or the measure of LAM is 26 degrees. The next thing we're going to look at is something called congruent angles. And of course, we already talked about it, so please tell your neighbor. Colloquially, what does the word congruent mean? And as we are talking about angles, the only real thing about angles that we talk about is that they have to have equal measures. They have to have equal measures. So they're both 22 degrees, they're both 53 degrees, etc. Eyes on deck just to see. Notice that this angle here and this angle here Are they congruent? And we say, wait a tick, this puppy looks so much smaller. But what does the arrow mean?
Oh, it goes on.
It goes on forever. So really, this is just like a snapshot of just this little section here. So how we mark congruence is we use a single arc, and it means those two angles are congruent. Now sometimes you're going to see it as a double arc, like this, or even up to a triple arc. So just to show another example, if I were to draw a parallelogram, for example, like so, one property of a parallelogram is that the opposite angles are congruent, and opposite angles are congruent here. And this is how we differentiate. Right now I'm stating that all four are congruent, but clearly this is acute and acute, and this is obtuse and obtuse. So how do we change that? I put a double on it. So now I'm saying these are definitely congruent. These are definitely congruent. I don't know if these ones are. They might be, but probably not. So we can use double, triple. You might see this on rare occasion. You also might see such that where they put a little tick inside instead. But generally we're going to use the single arc, double arc, or triple arc instead of the little ticks. All right, and of course we talked about segment addition postulate, which said this, that if we have two segments, you can add them together to make a bigger segment. This here says the same thing. It's kind of like I have a ramp right here, and I add another ramp to it, so now I get a really big ramp. Or I have a pair of scissors that I've opened up, and I open it even larger, so now I have a very large opening. So angle addition postulate says angles can be added together. So eyes on deck just to see how it applies to this example. Notice as I start with the angles, I'm going to talk about the numbers. So I'm going to talk about this angle right here, the measure of angle ROS plus the measure of angle SOT is equal to the angle, the whole thing, angle ROT. The measure of angle ROT. Now I can start substituting the values in. The measure of ROS is 4x minus 20. The measure of angle SOT is 3x plus 14. And we're told that the entire, and that's a Q actually, so not a, let me go back and change those. Q, and the whole thing is 155, which clearly is obtuse. So just like we did with the segment addition postulate, we can add two dimensions. So this is like the segment addition postulate two-dimensionally. That's all. And now we can solve this. I solve for x. I don't stop there. I don't circle it. I'm not committing to that as the answer because it didn't actually ask me what x is. It asks me what the measures of the two angles are. So now I'm going to put a 23 back into the x right there to find out what the measure of angle RQT is. And then I have to find out what the measure of angle SOQT is by plugging those back in. So I'll reiterate that for the video here, is when do I use the letters and when do I jump just straight to the expression added together and equal to the straight angle, which is 180. And the question, of course, or the answer is, if we ever say, use the segment addition or use the angle addition postulate, you should start with the generic formula there. And now from here, we can combine like terms to get 13x minus 2 equals 180. 13x equals 180. 2, excuse me, undo that. And then x equals, notice again we're not done. It did not ask us to find out what x is. We have to use x and substitute the x back in to there to find DEC and there to find CEF. And in the end, when you add the two together, it should be 180. So you can always verify that using the straight angle definition.